Okay, so we're leaving off on, I think, 41. So let me go back to Desmos. Because I'm not gonna sit here and draw this by hand. They're gonna be too off-center, I guess. So who is the inverse of secant? Cosine, right? And so notice this one has a shift of x plus pi over 4. Okay? If you want to click on these cells, you can see the tips of where the highs, the minimums, and maxes are. So if you do the same thing with negative cosine, and we're going to do x plus pi over 4. Let me close that. Oh, forgot the 5, sorry. What do you notice? So what I will suggest to you is draw the original variable, if you wish, first, and then go from there, and then you can see where the max and mins are for each of these respectively. Okay? Alright, so that's 42. 43. Now, 43 does not require Desmos, so let me go back out. This one says the angle of elevation from the top of a house to a plane flying. Well, obviously the plane's going to be, I guess that's what a plane looks like. Okay. Just in case you can't follow my art form, airplane. Okay, and here's a house. There's a door. Somehow you're standing at the roof, because they're saying you're at the roof of your house, so why you'd be there, I don't want to know. So the angle of elevation looks like that. And, okay, so it says D represents the horizontal distance of the in meters of the plane from the house. So remember, you're looking at this as the ground, and so this is D, right? And so we would assume the angle of elevation is theta. So whatever distance that is, that's going to be equivalent. What do we know? What are they asking? So we know that the plane is 7,200 feet from the ground, so that's the from the ground up. This is D, that's the horizontal distance, ergo horizontal distance. Alright, and they want us to find D. What is the value of D? So if we notice this is the hypotenuse, we don't need that. But we do know that this angle of elevation exists, and we have its opposite and its adjacent. It sounds like a tan function to me. And so if I'm looking at this from this perspective, it would make sense that you would say D is equal to cotan of that theta times 7,200. So basically we're trying to find this side, which is the adjacent side to this. You can think of this a couple of ways as well. It's not going to be 10 because I'm solving for D, and once I divide, it will become cotan anyway. So because we're using the adjacent and the opposite, so opposite over adjacent, that gives you the tan function, and the cotan function would be adjacent over opposite. Okay, so if I say cotan theta and I solve for D, you'd end up with this. 44, 45, more graphing. Let's go back to Desmos on those. I mean, you technically should be able to do these. by hand. Obviously, we've had a quiz on that, but the only difference in the next couple of questions is there's like a vertical shift. So I'll do a couple of these. And so at some point you will hear my child bellowing because she is behaving, or shall I say misbehaving at this time. Now she doesn't want to go outside. But she's going to stand here and yell at me for a minute. Alright, so I'm looking at this one, and if I'm graphing this function, that's what that looks like. Remember, it's negative and it's also shifted down. So instead of going through the traditional 0, 0 mark, so if I had negative, so if f of x, oh my goodness, is equal to negative tan, and let's go with the x plus, and then pi over 4. So that's how I do. Okay. And eliminate the uppercase. Apparently doesn't like the uppercase either. There it goes. Okay, so that's what the green is, the original function without the shift of -1. So you can see it's just dropping it down. Excuse me, your midpoint goes from here to approximately here, so it drops down 2 units, or close to 2 units. You have your quarter point, 3/4 point showing up as well. So that's what that looks like. Let me talk to you a little bit about the absolute value function, because we haven't really talked about that. So I'm going to do 2 secant absolute value of x. And let me erase this guy here. Alright, so we have f of x equals 2 absolute value, or 2 secant absolute value of x. So this one isn't showing up on Desmos very nicely, but let me give you a hint what the drawing should look like. I have like 9,000 papers on my desk here. This is 47. Yep, that is exactly what it will look like. You see nothing on your paper, because it doesn't exist. Okay, let's look at 48 then. Well, 48 is a cotan, and it is an absolute value. Maybe that one might be a little bit easier to show. So let's do this one. So 48, I have cotan of x over 2, absolute value. And so let me see if I pinch it in, will it do it? I should get a graph for this one. No. There we go. So this is what the graph should look like, and if I'm looking at it from just simply pi to 2 pi, so if you notice when I click on that, that's pi 0. That should be going through pi 0, and you should have the asymptote Let's see here, this will be at about x is 6. So if I draw a line at x is, nope, not 5, 6, okay. So at about x is 6, you should have a pretty clear distinction of the cutoff for the asymptote there. Alright, so I'm going to stop the video here for this one. This is the graphing part, and I'm going to start with questions 49 to 60, so we should be done soon.